Hi, pal. This is Tony Lockwood here. We're at the CAASE 18 conference. Now, this show CAASE is co-hosted by Digital Engineering, which I happen to represent, and by NAFEMS, which you need to know about if you don't. That's the International Association. It's for engineering, modeling, analysis, simulation community. You need to become a member. They really got it together. I have a great guest here from a company that has two names. It kind of confused me a little bit. It's Visual Collaboration Technology, VCollab. And please introduce yourself, introduce your company. And we're at a simulation conference. Why would engineers doing simulation be interested in what you have to offer?
Anyway, thank you very much for this opportunity. My name is Prasad Mandava, and as I said, I'm from this company called Visual Collaboration Technologies. I'm one of the co-founders of the company, and we are in the business of streamlining the simulation and communications.
Now, how do you go about doing that, streamlining?
All right. See, if you, the whole CAE space, as you know, is full of vendors who are developing the solvers, then the pre-processors and the post-processors.
Yes.
Now, as I think it's around 2005, one of my customers, a large automotive OEM, he mentioned to us, he called us and said they use one CAD system in the company across the globe, but they use 200 CAE solvers. 200.
200 to 1.
200 to 1. And out of which, around 50 to 60 are in-house developed CAE solvers. Mm-hmm. That's the complexity in the CAE.
Yeah, it is.
And every solver has an input deck, output format. You can imagine this, that communication is a nightmare. Right. So many formats floating in a company. Right. Whereas in the case of a CAD, being one CAD system, they are using some neutral formats to share it. They streamline the communication between manufacturing and design. So since the time, with the help of the industry, we have been developing a common format called CAASE. So that's what we are bringing in.
Right.
This we have been doing for more than a decade.
Okay.
Primarily from the inputs from the industry. So from all these 200 CAE solvers or whatever it is, they can export whatever they need into the CAASE file. And now all that they need to worry is managing a CAASE file. Mm-hmm. So that's the first contribution.
That's the first. Just the first. Oh my goodness, you got more, huh?
But once you have the format, you need to build the translators from all the solvers, which we have been building. And next, you have to, what do you do with the CAASE file? You need to visualize it. Mm-hmm. We have been developing the viewers, and that's a journey.
That's a journey. That's a journey.
Yeah, because you have so many users, right? So now you get to the fundamentals of, okay, what do you do with the simulation data? Who are the consumers to that?
Right.
So when you look at it, you're doing the whole simulation to validate a design. Mm-hmm. So the designer is really your customer. Right? So, and then you generate reports from that. How do you communicate with the designer? So you have to generate a report. If you look at it, I started as a CAE analyst in 1985.
Okay.
So I think somewhere around late 80s, I started using my first post-processor. If a solver generates a result file, I open it, I click, find where those hotspots are, write in a paper with a pen, go to the PowerPoint, put the boxes, type in my double position values. I create 5,200 slides. You believe it or not. That's what I did in 1989.
Right.
Even today, people do that.
Right.
That is something that didn't change at all.
Right.
Probably because I think 10 years back, when we spoke to the industry about this, they felt that most of the pain was in the pre-processing side. It was taking like 80% of the time if you look at the CAE process. You pre-process, you solve, you post-process.
Right.
It was not that big of a problem relatively. I think there's a lot of good work done in that area. The problem looks like pretty much, if not all, disappeared. Now with the cheaper computing, clouds, and people are able to solve much larger simulation problems, post-processing is becoming a pain. Recently, when we went to talking to one of the analysts, he said, at the end of every analysis, he spends like 1 day to 2 days to make a report. It's a process in the company. These guys are PhDs and they're masters. They hate doing that.
Yeah.
This kind of a manual process. So, as I said, while format is the first step, so we did a lot of work, interesting work in terms of the data mining and creating those anomalies, finding the anomalies, and creating a report, and then make the report into a 3D report. So it's no longer a 2D report, it's a 3D report. So these are the developments that we have been working in the past few years. How do you data mine the model, find those things, extract it, and instead of giving a 2D report, how do you generate a 3D report? Because now you give the report as a PowerPoint file to your designer. You mark a hotspot and you give it to him, right? And he looks at it and he has to modify the design. How does he do that?
Yeah.
It's very tough.
Yes.
So now you give it rotatable 3-dimensional model, you mark it, he can zoom in, he can see it, he can see the design in the context. He knows exactly where to modify, he can locate the point, he can do that. That is one of the big values. And number two, engineering became global, as you know. These files are so huge, 50 GB has become a norm, and some files goes into terabytes and even petabytes.
Right.
Now, an engineer in India, they outsource it. He solves a problem in India. The manager is in America. I can take an example. He sends a report as a PowerPoint. You cannot validate it. You're looking at a report, and what he sends is what you are seeing.
Right.
Now, the manager gets a doubt. Okay, what's the value on the stress value on the other side? You don't have it. You call the guy and say, hey, send me the file. That is 50 GB file.
Right.
You can imagine the inefficiency in the system. The 50 GB file takes sometimes 4 or 5 hours to come.
Right.
And processing that takes time. There's so much inefficiency the simulation world is living with. So again, when I said CAASE is a first step, then we started, the 3D report, the development of the 3D report, and what should be in it, and who should see what a designer wants to see, what a manager wants to see, what is the requirement for analyst to analyst communication, what is the requirement between, let's say, analyst to the designer communication. They're very different.
Right. Yeah.
So we have been developing this data mining techniques, different views for the different roles in the company, and adding the 3D slide capability. There's a lot of work that has been done. In addition to that, as you know, initially we plugged in the system into simulation data management systems. And originally the technology was they had to install a plugin to see it on the web. Now all the big companies like Google's and Firefox stop that. So we went to the next generation where we went to the HTML5 based. So now a large company do not need to install anything, but they can view this 3D report. That's a huge development again. It was an IT nightmare if you say, you take again automotive company, there are like 1,000 CA analysts and there are like 10,000 designers.
Right.
Now you generate the document, how do you share it to them? It's a big problem. Somebody need to install the viewer before they see the document.
Right.
So we developed, as I said, technologies where they don't need to install anything. They can share the document across the enterprise using just as long as they have the browser. So these are all the lot of developments that I've been doing. As I said, the format, how do you translate, and what kind of viewers are required for different people, what should be in the document, and how you data mine and how you automate. So those are the lot of work that has been done in this area.
Right.
In a nutshell, that's what we are doing.
I imagine that is what people are asking you to do for them. Please, help us get this information. We have to use this information in a number of ways by a number of different people, but it's the same information, but it needs to be different, and we can't keep sending 50, 60 100 gigabyte files all the time, and you know, coast to coast, continent to continent.
So the size of the file is an issue.
Right.
Storing them, moving them is an issue. It's
Viewing them.
Viewing them, yeah. And then for analysts to process it and getting the information out of it as a report is the biggest painful item. So we're able to even automate that process because of through the data mining.
Right.
So you're able to solve the large file issue. You're able to solve the IT issue, and you're able to save a lot of time. So the whole CA, as we discussed, is primarily to help make decisions on the design, right? So there is a lot of delay in that because of these things.
Yeah.
So we're able to now help with this technology make the decisions faster, streamline and cut down. So that's the direction we're going.
Very good. Fascinating stuff. I have your website as www.VCollab.com, and you can write the digital engineering editors, and I'll make sure that you get the address for that website. There's a lot of interesting things on there that you want to learn about and see. I can't thank you enough for spending a few minutes with us and our viewers. Thank you so much.
Thank you very much.
Have a good evening. Enjoy the
You
rest
too.
of the show. Thanks for watching, pal.